This is lesson 6.1, trigonometric ratios for any angle in standard position. In this lesson, the focus is on using the unit circle that we learned about in Pre-Calculus 11, to determine trig ratios for angles that are less than 0 degrees and greater than 360 degrees. If you recall from last year, we were only dealing with angles that were between 0 and 360 degrees. Before we start this lesson, what we need to do is we need to recall a number of different concepts that we worked on in Pre-Calculus 11. So we'll start with that. The first concept that I want to do is I want to recall what standard position is. So if you can write this down, standard position. So we're going to hear this term a number of times. Standard position works like so. If we have our x-y axes like this, and maybe I put an angle in the third quadrant right here, let's say maybe 200 degrees. We talk about standard position as it starts on the positive x-axis and works its way counterclockwise. So we would express standard position like so. Okay, so standard position kind of always tells us where we start. All right. The next concept that I wanted to do with you is this concept of coterminal angles. Okay, and if you had me as a teacher last year, I definitely went over this concept with you because it's not really too much of an extension, even though last year it really wasn't a part of the curriculum, you could say. Coterminal angles work like this. Let's say we have an angle in standard position of 300 degrees. So let's say 300 degrees looks like this, so I'll just express that as 300 degrees. We can say that if we kept going, if we did another full revolution, so let's say we went and did this to 300, and then we did another 360 degrees like that, we would of course get this angle of 660 degrees. What we say about those angles is that they are coterminal. So angles that we can add 362 or perhaps subtract 362 are always going to be in the same position. They have the same position on our xy axes like that, and so therefore we call them coterminal angles. All right, so it's a relatively easy concept. You can just basically take any angle, add or subtract 360, and they are coterminal. The next concept that I want to deal with you, and this was a big part of Pre-Calculus 11, was dealing with those special triangles. And all I wanted to do right here was just remind you what those special triangles were. So there's two of them. The first one is relatively straightforward. This one is the 45-90 triangle. So of course this makes a nice isosceles triangle where these sides must be the same. And the side lengths of these, because these sides are the same, is 1, 1, and root 2. Those are the ratios that they fall. All right. So while not every triangle, of course, is going to have lengths 1, 1, root 2, the ratios will always be the same. The second special triangle we get looks like this, let's say. So it's, of course, not an isosceles triangle. This angle is 30 degrees. Let's call this angle 60 degrees. Of course, this isn't perfectly drawn to scale. And so how it works is the smallest angle, 30 degrees, has the smallest side, 1. The next smallest angle has the next smallest side, root 3, and the hypotenuse gets 2 like that. Okay, so those are special triangles that you're definitely going to need to know in order to be successful in this unit. Okay, and then the last concept that I wanted to do on this front page here was this concept of the cast rule. Okay, and so I'll first just write what the cast rule was. The cast rule told us if those are our xy axes, we have C, A, S, and T like so. Now, what is this all about? Well, the cast rule tells us which trigonometric ratios are going to be positive, and you could also figure out which ones are going to be negative. So the C stands for cosine, the A is all, the S is sine, and the T is tangent. All right. And so if I asked you which two quadrants is tangent positive, we would say it's in the all and in the quadrant 3 in the T. And so if it's positive in these two, it must be negative in these two like so. Okay. And just quickly to remind you how we know this, if you remember, if you had me again as a teacher before, I talk about we express our triangles like a bow tie like this, not like an hourglass. But if you think about the directions that we go on our xy plane right here, we've gone in a positive direction here, and positive. Okay, so we always have our hypotenuse for every single one of these is positive. The reason for that, if you recall, is that when you do Pythagoras, if we call this a squared, we call this b squared, regardless if they're positive or negative, the hypotenuse is always going to be positive. So in any event, if you look in this first quadrant here, you'll see that everything is positive. So that would make sense that all of our trig ratios, A, are going to be positive. If you go this next quadrant right here, we would go in the negative direction, and then we'd go positive up here. And so we know that sine is positive here, and the reason sine is positive is because your opposite over here, a hypotenuse, a positive and a positive makes obviously a positive. But if I was to ask you for the cosine, you would have negative over positive, or tangent, it would be positive over negative. Okay, so I'll just fill out the rest of this table right here. But this, anyways, is where we derive the cast rule from. Okay, so that was super quick, but that is the concepts that we covered in Pre-Calc 11 right here. So all of these things, and if you have a good beat on this, then we should be ready to go. Example 1 states, determine the measures of all the angles in standard position between negative 800 degrees and 800 degrees that are coterminal with an angle of 85 degrees in standard position. And then finally they want us over here to sketch the angles. First thing we're going to do though is we're going to start with 85 degrees, and we're simply just going to add 360 as many times as we can such that we stay under 800 degrees. So if I add 360 degrees to that, I have my first coterminal angle of 445 degrees. Okay, so that's my first coterminal angle. Next from there, what I would do is I would continue to add 360 degrees. So if we add 360 degrees again, the problem that you'll see is that we are now over that 800 degrees that we were looking for. So now we'll go back to 85 degrees here, and let's go and subtract 360 degrees. And so when we do that, we're going to have an angle that's, of course, going to be negative. So it's going to be negative 275 degrees. So this angle right here would be coterminal as well. And then what I'll do from here is I will keep going. Now this example right here, we can go and subtract 360 again. So I'll go back to my 85, and I'm going to subtract 2 times 360 degrees, which of course is the same as subtracting 720. And this gives me my final coterminal angle of negative 635 degrees. Okay, so these are my coterminal angles. Let's go and put these in standard position. So 85 degrees, of course, is in quadrant number 1. So 85 degrees would be about, let's say, right here. So I'll express that as being 85 degrees. Okay. The next one I'll do is 445 degrees. So this would go all the way around to 360, and then we go another 85 degrees, just like so. And so that one would be 445 degrees. Okay. Now the other ones are going to go in the opposite direction. So they would start right here at 85 degrees. And then they're going to go all the way around like so. Okay, so this angle right here we would say is coterminal, and it is at negative 275 degrees. And then if we were to do one more, it would have to go all the way around. It gets kind of complicated here, but like so. And we would say, if I make my terminal arm a little bit longer, that this would be negative 635 degrees right there. So the interesting thing is, of course, that every single one of these angles, of course, that's the definition of being coterminal, hits at the same spot in standard position. Okay. Finally, B here says, write an expression for the measures of all the angles that are coterminal with an angle of 85 degrees in standard position. So again, this is really straightforward, and this is basically what I had just done up here when I was showing you that it's basically just successive multiplications of 360 degrees here. All we would do is we just take our first angle, 85 degrees, and we are going to add k times 360 degrees, just like so. Okay, so sometimes what we can do is we could, if we wanted to go and make k 1, we would just put plus 1 times 360, or 2 times 360, or we could also do negative as we did up here. And so if you put in any value of k, you will produce angles that are going to be coterminal with 85 degrees, just like so. So the next thing I want to do really quickly here was just talk about what the equation of a unit circle is all about. And the equation of a unit circle just says that if we have a circle that's located where the center is at the origin and a radius of 1 unit, so it's saying that if this terminal point is anywhere around this circle, the radius is always going to be 1. It has the equation x squared plus y squared equals 1. And this really shouldn't be too surprising because it's just Pythagoras going on here. If you take a look here, we have x squared, so make that your a, if you will, and then we have y squared, and then that's equal to the hypotenuse, which is 1 all squared. Now, this simplifies ever so slightly such that we get this equation of the circle just because 1 squared, of course, is just equal to 1, okay? Okay, so on this page you'll notice that we have a very similar drawing, but you'll notice that we have our terminal point right here. That just means it's ending on our unit circle right here. A terminal point, and it's located at cosine theta and sine theta. And so I want to show you how we can express these dimensions x and y in terms of our trigonometric ratios. Okay, so we have our right angle just like so, and you might wonder, well, why do they have, like, why is the location of that point right there cosine theta and sine theta? Well, I want you to think about these ratios right here. So imagine I asked you to set up the ratio of cosine of theta first. Okay, So remember, the ratio for cosine is your adjacent over your hypotenuse. So what we're going to do right here is, if you take a look, if this is theta, my adjacent would be x, and my hypotenuse is 1. So we have cosine theta is equal to x over 1. Well, if we reduce this, you'll notice that x divided by 1 is just the same thing as x, so we have cosine theta is equal to x. So hopefully that makes sense, that the distance going along this axis right here is actually x is equal to cosine theta. So this is cosine of theta, and that's where they get the x coordinate of our point. Now, likewise, we can do the same thing with sine. Sine of theta, if you recall how sine works, it is your opposite over your hypotenuse. So this would be y over 1. And of course, that just simplifies to be sine of theta is equal to y. All right? And so this dimension right here is sine theta, and that's how we get this sine theta right there. Because remember, this ordered pair is my x coordinate and my y coordinate, like that. Okay? And just to make the point here as well, if we did want to know what tangent of theta is, in this case it would be just y over x. Okay? And so finally, something new, definitely, that we're getting right here is we get these reciprocal trigonometric ratios. Now, if you remember what a reciprocal is, the definition of reciprocal is it's any number that you multiply by another number such that it gives you 1. Well, we have some different ratios that you're going to be introduced now. The reciprocal of cosine is written as secant, and we express it as SEC, so we'd write this as secant theta is equal to 1 over x. And you'll notice that that is just the reciprocal of what we had right here for cosine theta. Okay? So it makes sense that the next one for sine of theta is going to be 1 over y, and you'll see that it is 1 over y, and we call that one cosecant. Okay? And then finally, tangent also has a reciprocal ratio like so, and we call it cotangent, and that's just flipped x over y. Okay? So let's take a look at a couple examples right here where we'll start looking at all 6 of these trigonometric ratios. So we're not just dealing with sine, cosine, and tangent. As you see now, we have secant, cosecant, and cotangent. All right. So example 2 says determine the exact values of the 6 trigonometric ratios for negative 420 degrees. So what I want you to do, if there's one thing that you hear in this lesson that I find students kind of don't notice, is this exact value means you're not using your calculator. This one right here, approximate values, means that you are. All right. So if you might even want to make a note of that. So no calculator for something like this. Okay. So that means that we're going to be referencing our special triangles. So let's first find out which quadrant 420 degrees is in. Negative 420 degrees, I should say. So negative 420 means we're going clockwise, so this would go all the way around to 360 degrees, and then you'd have to go 60 more degrees. So it'd be in quadrant 4 right here. We'd express it like so, so we'd write the angle, and it would look like this, just like that. And so I'll label that as negative 420 degrees. Okay. So what it would do is it would end up making this terminal arm like that, and so we'd have a triangle, kind of an ugly triangle, but I think you get the gist. Now, what I want to do is I need to figure out what my reference angle is. And if you remember what the reference angle is, it's this little angle right here that falls in our triangle. It's always between 0 and 90 degrees. And so if you think, how many degrees am I away from the x-axis? That's always how you determine your reference angle. It's never the y-axis right here, always the x-axis. So that's where that bow tie thing came in. So if we have our bow tie like these little angles in here are always your reference angles. And so in this case, my reference angle is actually 60 degrees because that's how far I've gone from this x-axis. So I'm going to write 60 degrees in there. You'll notice that if that's 60, then we know, of course, that this is 30. We have our 30, 60, 90 triangle, and now we can set up everything that we need to know. Opposite of the 30 is my 1. Opposite of the 60 is my root 3, and opposite of the hypotenuse is 2. But the one thing you need to be careful of is remember that if you've gone in the any negative directions, we haven't with the 1, but with the root 3 we have. Hypotenuse is always positive. So finally now, they just want you to express all the trig ratios ever so quickly. So sine of negative 420 degrees just means that you're going to take your opposite, which is negative root 3, and you're going to put it over your hypotenuse, which is 2. So you'd have negative root 3 over 2. Cosine of negative 420 degrees. We will take our adjacent, which is 1, and we'll put that over 2. And then we have tangent of negative 420 degrees. Tangent is your opposite over your adjacent, so we just have negative root 3. Okay. Now what we also want to do right here, and I'll just express this maybe in our pink color right here, is we want to express what the reciprocal ratios are going to be. So let's start with the one that matches up with sine, and so that is cosecant. So cosecant of negative 420 degrees is going to be just that flipped up. So we have negative 2 over root 3. I always like to put the negative up top, as you can see right there. The next thing we have is we have secant. So secant of negative 420 degrees. And of course, that is the reciprocal ratio for cosine. And so that one's just going to be 2 over 1, or just 2. And then we have cotangent. Cotangent of negative 400 degrees. And that's going to be the reciprocal of this, which is negative 1 over root 3. Okay, so the big thing I want you to understand right there is that the exact value means that you're going to have to go and use your special triangles like so. All right, so let's go and do one where you don't have to use your special triangles, where you're just using your calculator. All right, so B here says determine the approximate values of the 6 trigonometric ratios for 586 degrees to the nearest thousandth. First of all, 586, it's impossible to use one of our special triangles, so therefore, and it says approximate right here, we're going to have to use a calculator. So make sure that you note that. So those are my 2 little tips, like so. So what we'll do here is let's just set this up. We're going to look for sine of 586 degrees. We'll look for cosine of 586 degrees. And then we have tangent of 586 degrees. Now I've taken the liberty of already putting these into my calculator. And when you do that, you're going to get the following that we have right here. It shows up that sine and cosine are going to give you negative values, and tangent is going to give you a positive one. I just want to go over that for a second. If you think of where 586 is, if I just drew you a picture like that, we'd go all the way around to 360 degrees, and then we'd have to go a little bit further such that our angle would have been in this quadrant right here. Okay, so if you were just to subtract 360 degrees from that, you would end up having 226 degrees, and so that would put you in this quadrant right here, quadrant 3. So it makes sense that the tangent ratio is going to be positive. So going back to my calculator, I will round this to the nearest thousandth, so that is 10th, 100,000th. We're going to 3 decimal places. So this gives me 0.719, and of course that one was negative. This one's going to be negative 0.695, and then we have 1.036. Okay. Now, the part that's going to be a little bit more interesting for you is how we're going to find the next ones. Okay. So how are we going to find out what cosecant 586 degrees is? How about secant of 586 degrees? And lastly, cotangent of 586. And I'll just show you how to do one of these. Let's actually do that last one right there, just because it's the one that's last on my calculator. All you're going to do here is you just need to take the reciprocal of it. The easiest way to do that is you just raise it to the power of negative 1. And when you raise it to the power of negative 1, you get the ratios that we're going to do. And so I will write down the answers for these. I would encourage you to try this on your own. So just take the answer for all those ones that we had before and raise it to the power of negative 1. And so when you do that, the values that we'll get is remember we're rounding to 3 decimal place, is 0.966, negative 1.43, I guess 440, and then we have negative 1.390, like so. Okay. So that is how you deal with those. Maybe just make yourself a little note. In order to get from here to here, you're just going to take the solution and raise it to the power of negative 1, like so. Okay, let's mosey on. Okay, so here we have the equation of the circle. You'll notice that this looks very similar to what we had before, only we replaced the radius with r, because our radius doesn't always have to be 1. What I want you to do right here, or to join me with, is writing all the different trig ratios that we can derive from this. Okay, so if we start out with cosine, we have cosine of theta, and how do we find out what cosine of theta is? If we want to get, like, let's say that terminal point right there, cosine of theta is going to be equal to x, my adjacent, over my hypotenuse, x over r. Okay, and because we have cosine of theta is equal to x over r, that tells you that secant theta would have to just be the opposite of that, r over x. Okay, next let's deal with sine of theta. Sine of theta is going to be equal to y over r, and that would make sense that cosecant of theta is equal to r over y. And then lastly right here we'll do tangent of theta, and tangent of theta is y over x, and that would make sense that cotangent of theta is x over y. Okay. All right, example 3 says we have point P, which is located at negative 1 and negative 4. So let's go and plot that first. So that's where that point's going to be. So it's going to make my triangle look like so. Okay. Actually, let's just label it as negative 1 and negative 4. Let's see what the question's asking. So that point is a terminal point of an angle theta in standard position. Determine the exact values of the 6 trigonometric ratios for theta. Okay, so once exact values, that means we're not going to really need to use your calculator for this. It means they don't want any rounding. Because I know that this is -1, this is -4, it would follow that I could figure out what the hypotenuse is by just using Pythagoras, so I'll do that. So that takes -1 squared plus -4 squared, and that will be equal to my hypotenuse, which we'll call r. -1 squared is 1, plus -4 squared is 16. And so this is going to give me 17 is equal to r squared, or r is going to be equal to the square root of 17 once we solve for it. So I'll just write root 17 like so. Okay. And now what it wants you to do is it just wants you to write the 6 trigonometric ratios. Okay. So not too terribly tough. We have sine of theta, so we're basically just using the exact same rule that we learned about right here. We'll start with, yeah, it doesn't matter what we start with. We'll start with sine, I guess. Sine of theta is equal to, so sine of theta is going to be, that's my reference angle right there, so it's my opposite over my hypotenuse, so -4 over root 17. And that would make sense that cosecant of theta would just be equal to the reciprocal of that, so -root 17 over 4. Let's deal with cosine next. Cosine of theta is going to be equal to -1 over root 17. And then we know that secant of theta is equal to just -root 17. And then finally here we have tangent of theta and cotangent. Oops, cotangent of theta. So tangent of theta is going to be -4 over -1, which gives me a positive 4. And we should expect that, right, because that's the quadrant where tangent is positive. And then lastly, to find cotangent, we just need to take the reciprocal of that, which gives us 1/4. Let's go to the back page. Example 4. Suppose secant theta equals 4. Determine the exact values of all the other trigonometric ratios between 0 and 180 degrees. So if we draw between 0 and 180 degrees, right, we're just talking in quadrants 1 and in quadrants 2. So that's a big thing to point out right away. So the first thing I get you to recall is I get you to recall what the secant ratio is. So on the previous page right there, we learned that secant of theta is equal to r over x. And because we know that secant theta is equal to 4 right here, it would follow that we know that r must be equal to 4 and that x must be equal to 1 like so. Okay? So if we were to express this on our grid right here, we could draw basically our picture such that we know that r is going to be equal to 4 and the x coordinate is going to be equal to 1. We could determine what the y coordinate is going to be right here. Okay, so let's go and do that first. To get that y coordinate, we'll just use Pythagoras again. So we have x squared plus y squared is going to be equal to r squared. We know that my x is 1, so we have 1 squared plus y squared is equal to then 4 squared being my r. This gives me 1 plus y squared is equal to 16, and y squared is equal to 15, or y is equal to the square root of 15. Okay, so we now know all of our side lengths right there. So because it wanted you to get all the other trig ratios, that's basically all you have to do right here. Okay, so this one was just kind of working perhaps a little bit backwards compared to the last question. So I'll express all our answers here in this pink color. So we've dealt with secant, that's done. Let's write all the other ones. Okay, so if secant is equal to this, I'll just write this next one right next to it. It would make sense that cosine of theta would just be equal to 1/4. Okay, so that those ones are done. Let's go and deal with the rest down here. So we have sine of theta would be equal to root 15 over 4. And the reciprocal of that one would be cosecant of theta is equal to 4 over root 15. And then we have tangent of theta and cotangent of theta. So tangent of theta would be equal to root 15 over 1, and cotangent of theta would be 1 over root 15, just like so. Okay. What else do we need to do for this question? Anything else? The one thing that might kind of interest you right here is how did I know that I didn't need to deal with anything in this quadrant right here? Because you remember at the very beginning this question said it's between 0 and 180 degrees. So it means I could have had also ratios in this quadrant. The one thing I get you to realize is that secant theta matches up with cosine. And in this ratio, or sorry, in this quadrant right here, remember our cast rule. Maybe I'll just express cast rule for us again, C-A-S-T. I know that cosine in this quadrant is going to be negative. And because I saw that this is a positive value right here, that's why I didn't express any of my angles in that quadrant. Okay. All right, lastly, B. To the nearest degree, determine possible values of theta in the domain between negative 360 degrees and 360 degrees. So if we go back up to our question right here, you'll notice that before we were only worried about between 0 and 180 degrees. Well, if we look at right here, we're going to blow it open a little bit such that we're looking at between negative 360 and positive 360. The ratio that we start out with was secant theta is equal to 4. What I would encourage you to do, because we're going to need to find out what theta is just first in that quadrant 1, is I'm going to go and deal with the regular trigonometric ratio, not the reciprocal ratio. So because I know that secant theta was equal to 4, I know that cosine theta is equal to 1/4. So I'm going to drag that information down here. I'm going to let that help me out. So I'm first just trying to identify what theta is. So cosine of theta is equal to 1/4. We knew that from above. And that tells us that theta then must be equal to the cosine inverse of 1/4. And if you put that into your calculator to the nearest degree, you get 76 degrees. Now, the next thing we need to do is we need to figure out, because we have to obey the cast rule right here, we have to figure out which other quadrants cosine is positive in. So we know that cosine is going to be positive in the A quadrant, of course, but it's also going to be in this fourth quadrant, the C one right here. Okay, so if we're trying to find all the other angles that are possible right here, we have to pay attention to these two quadrants. So let's deal with this first quadrant right here in quadrant A. So could I go and take 76 degrees and add another 360 to it and get something that's less than, or that's in this region? No. But I could start at 76 right here and subtract 360 degrees. So that's going to be one of my possible angles. Okay, so what I will do now is I'm going to take 76 degrees and I'm going to subtract 360 degrees from it, and that's going to give me negative 284 degrees. Okay, so that's one of my angles, and this was the other angle, like so. Okay, now let's go and deal. So we've dealt with this quadrant. That one's good to go. Let's go and deal with this quadrant. That reference angle is 76 degrees. Therefore, this reference angle is going to be 76 degrees right here. Okay. Well, where is that actual angle located at? Well, that means you'd go all the way. So we start at standard position, go all the way to 360, and come back and come back 76 degrees, which would tell me that this angle right here in standard position is worth 284 degrees. Okay. So that means that 284 degrees is going to be another angle. So 284 degrees. And now we need to figure out, are there any angles that are coterminal with 284? Well, 284, we can't take it and add 360, but again, we can go and take it and subtract 360. So we'll take that information over here, 284 degrees, and we'll subtract 360 degrees. And we determine that our other angle that we're going to have would be negative 76 degrees. Okay, so these four that I have in yellow, plus or minus 76 and plus or minus 284, would be the four different angles that are in this region right here and give us ratios of cosine of theta is equal to 1/4. Okay, so a complicated question there at the end. There's a lot of stuff going on. The tough thing really is just determining what two quadrants we're dealing with and what those reference angles are. And then once you have those reference angles, then you can try to figure out which angles are going to be coterminal to that. Okay, so a fairly lengthy lesson, no doubt about that, but hopefully most of the stuff wasn't too complicated, mostly just review from Pre-Calc 11. Thanks.